Hydrogen, helium, lithium, beryllium, boron, nitrogen? Oh, carbon. I always messed that one up. Dear Tim and Moby, how can two atoms of the same element have different numbers of neutrons? From Gabriella. Whoa, good thing we've got the periodic table of elements handy. Let's look at an element as it's represented on the table. How about, say, chlorine? Cl is the symbol for chlorine. That number above the symbol is the atomic number for chlorine. The atomic number of an element tells you how many protons are in each atom. Every single atom of chlorine in the universe has 17 protons in its nucleus. The nucleus, as you should remember, Moby, is the cluster of particles at the center of the atom. It's made of particles called protons and neutrons. This number is the atomic mass for chlorine, and it tells you how heavy chlorine atoms are compared with atoms of other elements. Atomic mass is measured in atomic mass units, or U, so chlorine's atomic mass is 35.453 U. Well, the atomic mass you see on the periodic table is actually just an average mass. Not all atoms of a given element have the same atomic mass. So every chlorine atom has 17 protons no matter what, but the number of neutrons can vary. Some chlorine atoms have 18 or even 20 neutrons. Isotopes are atoms of the same element with different numbers of neutrons. An isotope is called by its mass number, the number of protons plus the number of neutrons in its nucleus. There are two naturally occurring isotopes of chlorine. Chlorine-35 has 17 protons and 18 neutrons. Chlorine-37 also has 17 protons, but it has 20 neutrons. About 75% of chlorine atoms are Cl35, and about 25% are Cl37. Chlorine-37 is heavier than chlorine-35 because it has those two extra neutrons. So there you go, isotopes in a nutshell. Don't I get a break yet? Hydrogen, helium, lithium, beryllium, boron, carbon.